Hello everyone, welcome to our channel Knowledgignita. Let us study pharmacodynamic study. This is a study dealing with the effect of drugs on the body. So we take drugs, those go to our systemic circulation or in our body. So what is its action to our body? We will study that in our pharmacodynamics. So generally what does it mean? It means what the drug does to the body. In this we will study the drug action as well as their mechanism. So drugs generally act by these mechanisms. So first one is our physical mechanism. Physical mechanism is shown by, for example, our osmotic diuretics. And the second one is chemical mechanism. This is shown by, for example, our antacids. We take antacids orally. So it neutralizes the chemical and thus our action is shown. And next one is stimulation or inhibition of enzyme. Competitive inhibition and non-competitive inhibition is its example. So the inhibition or stimulation of certain enzyme is needed for us. And the last one is via receptors. We will study the receptors in our next video. Let us study enzyme inhibition now. So before studying enzyme inhibition, let us know about the enzyme. Suppose this is our enzyme. Enzyme has two sides. One is its active side and another is allosteric side. So normally enzyme, and this is our substrate. So enzyme substrate goes and forms enzyme substrate complex, then it forms enzyme plus our product. So the substrate binds to our active site. So after that our enzyme substrate complex forms, and this forms our enzyme plus product, which is our desired one. So the enzyme and substrate goes on a reaction, and here we can see our Km and Vmax. So let us see what is Km and Vmax. So Vmax is our maximum reaction velocity. Maximum reaction velocity is our Vmax, and Km is our Michel maintenance constant. So in Lineweaver Burk plot we can see our Km. So Km is Michel maintenance constant, and it is calculated as the amount of substrate required to produce half of maximum velocity. So this is our substrate concentration. So Km is needed to produce half of Vmax. So this is our Lineweaver Burk plot, and enzyme inhibition is of two types. So let us study competitive inhibition. So this is our enzyme, substrate and inhibitor. So in competitive inhibition what happens? Our substrate goes to active site and our inhibitor also goes to the active site. So this is our reaction, enzyme plus substrate plus enzyme plus product. Here our inhibitor binds to our enzyme. So it binds to our active site of the enzyme. In competitive inhibition, our inhibitor binds to the active site, not to the allosteric site. It binds to the active site only. So what happens? Our enzyme and substrate when binds, so it forms a certain substrate. When our inhibitor comes and binds to the active site, then certain amount of substrate remains. So that do not produce our enzyme and substrate. So this type of reaction can be reversible if we give more amount of substrate. Then what happens? Our inhibitor will detach from this active site and the substrate will bind. So that's why here our Km increases and Vmax remains unchanged. If the binding is non-covalent, then this produces our reversible enzyme inhibition, and the binding is covalent, means if the binding is strong, then it produces our irreversible enzyme inhibition. So for competitive inhibition, some are needed. First is our inhibitor binds to the active site. Inhibitor binds to the active site, and the inhibitor or a drug, its structure should be as same as of the substrate. Otherwise, what will happen? It do not compete with our active site. So if it fits to our active site, then only this will happen. Otherwise, our enzyme inhibition won't happen. So as I told, more number of substrate is needed to switch the inhibitor. So that's why our Km increases and Vmax remains unchanged. So now let us study non-competitive inhibition. First we studied our competitive inhibition, and we will study now non-competitive inhibition. In non-competitive inhibition, what will happen? There will be no competition between our enzyme substrate and inhibitor. What will happen? This is our allosteric site, and this is our inhibitor. So the inhibitor will bind to our allosteric site. After that, wherever the inhibitor will find enzyme's allosteric site free, it will bind there, and this reaction will hamper. Like inhibitor will bind to enzyme here, and after enzyme substrate production form, inhibitor will bind here too. So here what will happen? Our Km will remain unchanged because we are not giving much of substrate. If we give much of substrate also, this the substrate will not attach here. Substrate will attach here. So if we give also much substrate, then this reaction, the substrate will not sweep away this inhibitor. So in non-competitive inhibition, what happens? Our Km remains unchanged and our Vmax decreases. Like our maximum reaction velocity decreases, and the inhibitor binds to our allosteric site. Like this is our allosteric site. Inhibitor binds here, and the drug structure is not needed to be at same edge of the substrate. Like this is our substrate, and our drug structure can be this, but not at same edge of the substrate. So in non-competitive inhibition, it is different from competitive inhibition. Like in competitive inhibition, there is a competition between our substrate and our inhibitor. But here in our non-competitive inhibition, there is no competition between our substrate and inhibitor. Inhibitor will come freely and attach to the allosteric site wherever it will find the enzyme's allosteric site free, whether the free enzyme or in the enzyme and substrate complex. So the last type of inhibition is uncompetitive inhibition. So this is the whole pictorial representation of our three types of inhibition. So in uncompetitive inhibition, what will happen? The inhibitor will bind to a separate binding site. Inhibitor will bind to only enzyme and substrate complex. So that's why here the both Km and Vmax will decrease. So just remember, in competitive inhibition there will be competition between our enzyme and substrate and inhibitor. That means substrate and inhibitor competition will be there in competitive. In non-competitive, inhibitor will bind to allosteric site. In uncompetitive inhibition, this is different from these two, because here the inhibitor will bind to our enzyme substrate complex. So this is important. Just remember, in competitive inhibition, our Km will increase and Vmax will remain unchanged. Why? Because we need to give much substrate to achieve the reaction, and in non-competitive inhibition, Km unchanged and Vmax decreases. Why? Because here binding is to our allosteric site and not much substrate is needed. If we give much substrate also, it will not sweep away the inhibitor which is bound to our allosteric site, and in the last, the Km and Vmax both will decrease. Thank you.